Hello everyone, welcome to this video. In this video, I'm going to show you how to define the material property and section properties in Etabs. Why? Because in Etabs, especially reinforced concrete, we need to select the material properties and section properties for our design. So how to do that? I will show you shortly. First of all, go to open Etab model, go to create new model and build in. We use in Thailand we use metric MKS, and this one is quite important now because of the standard in steel section. We need to use AISC 14 and steel design code. We use AISC 360 16 and concrete we use ACI 318. So it depends on your where you live and which country you from. You can select a range of standard here, and I will use the template grid only. So when we come to here, uh, in the last previous video I show you how to do 2D structures and analyze them already. So in this we will use it helps to model to design the real structure like in the real life. So we need to set the properties and sections exactly what we want to design. First of all, uh, let's go to change the unit. So we will use the unit in KSC or kilogram force per centimeter square. So we need to change the unit to, okay, again, consistent unit to be centimeter and kilogram force. If you use ACI, if you use SI stand unit, you can set to be kilonewton. So to set the material, we go to define in the menu bar and select material properties. In eTab, they will have the in eTab they will have the some default standard, some default material that they automatic set for us. If you can check if you want to check. For example, the first one, this code, maybe if you don't understand, we can click modify and see what is it. So it is a steel section, or this one, concrete, and it's a concrete. But if you very familiar with this code, you can select immediately. So for me, I'm not very familiar. I need to check, make sure what is it. So this is the standard for rebar. So this one is the default one, but if our project or our assignment that we get, I think we need to select the proper design that available in where we live. So in this case, I will choose my material property for concrete. So for concrete, we can either add new material or add a copy. Okay, let's see for concrete. Let's add new material and we change the material. I want to create a concrete material. So the standard, I will use user define. Okay, just like this and click. Okay, now we can change the name. So for example, I want my concrete strength to be 240. So I name it like this and then select concrete. Now this one is okay. The color is okay. And unit weight. Unit weight. Okay. Unit weight we change to user define user specific. Why I cannot? Okay. Click specify unit weight. So this one is correct already. Sometimes it may change a little bit, but actually it is 2,400 kilogram per cubic meter. And modulus of elasticity, we can use the concrete formula to calculate the modulus of elasticity. So sometimes it may change based on the testing standard, but it should not change much. And then the next is to modify the material property design data. This one is the important one because this one we need to set the compressive strength. This is the real parameter that we want. So I want it to be 240 kc and click OK. The next, I think that's all for now. Okay, now click OK. It should come here, right? You can see it 200 kc. And the next, if you want to create another one, just if it's for concrete, okay, we can use the command add a copy of it. So the property gonna be similar, but the strength we can change to be different. So I change this one to be FC prime 228, for example, KSC, and name it like this, and change the color to be green. Okay, now we can show modify property or this side. This one we need to change. Don't forget this one is the most important for concrete design. And click OK and OK. Now we get two already. So how about how to create the steel? So steel we can go to click the steel, check it. Okay, it's correct. So actually we can just use this one and modify it. So if we don't want it to be like this, we can name it to be anything. I will name it steel tube. Okay, you can name anything as long as it still in the steel stand property. So I use color red and steel. Actually, we don't need to change much about steel for the elasticity and density because they have the quite obvious uh, density. But the next thing is to modify it. This one. So this one, the yielding strength in steel design, there are a lot of different properties, different yielding strengths. So we need to set the proper one. So in this case, let's say I will use, let me see, I will use, okay, I use a STM A36 and so the yielding strength is 250, sorry, 2500 KC to about 4 to 5,000. So let's say just use it to be 2,500 and ultimate strength to be 4,000. This one is the modulus of elasticity. It is like this, but okay. In Thailand, we use the exact number like this. So it does is I think it's not really matter, but if you want to change to be exact, it can be like this. So click OK. So if you want to add more, you can. The next is rebar for concrete, for reinforced concrete design. it's very important to set the proper material. So in this case, I will just modify it. Okay, this is a rebar, it's correct. If you want to create other material, you can add mercury, tendon, coform, or aluminum. So sometimes I use the wood structure. We can use the other and set the property. In this case, let's use only rebar. Rebar to be green, okay. And material, okay, it's oh, don't need to change. And okay, modulus of elasticity and modify this one. This one is the important one. So let's say, okay, I will name this first. I will name this string to be SR 24. The grade is SR 24 and modify data again. So SR 24, the strength is, okay, SR 24 is yielding strength is 2,400 and ultimate strength 3,900. Now click OK. The next I want to add, this is usually used for stirrup and uh, it is a round bar crate. Now let's go to modify it and change to deform bar standard. Great. So I will name it to be let's say use SD40 and change color blue. And no need to change anything here. This one, okay. And modify the strength. So SG40, that means yielding strength is 4,000. And ultimate, I forgot. Ultimate is this one. Out. Okay, this one is the ultimate for tensile. Um, they call it tensile here, but yes, it still is only used to resist tensile, and this is the same as ultimate strength. So it is 5,700. Okay, that's it. Now click OK. So we get steel section, we get rebar and concrete strength already. So everything complete. Now we have the material, but we haven't got the section yet. So we need to define the section. Define the section, just go to define again and go to section. Now for beam and column, we go to frame. And they have some default section here already. You can either do the same like add, copy each kind of section here. For example, concrete beam, we can just copy the property and set it again or modify it. Or you want, if you don't want any of this, you can import the new section. Okay, let's say, sorry. Okay, let's say we want to create a concrete rectangular tube. So, concrete rectangular section. So just click there and I think no need anything here to change. If you have the preferred standard, you can choose it. And we set this to be concrete. The material that we set earlier, we need to choose our section based on the material. So I will use FC prime, the strength to be FC prime 240 and click OK. I think this one can name later. Okay. Oh, okay. In this case, we can double click on it or modify it. So let's say double click and why cannot change? I think we need to, this one. We need to convert to user define. Okay, click this one. Now we can edit it to be, okay. I will create the beam. So I use beam one and color, any color. Now set the section, assume section. Let's say this uh, 50 centimeter by 25 centimeter. And what is next? Okay. In the right hand, you see the property modifiers. This one is about setting the area factor or moment inertia factor or cell weight. If we use one, that means we use the cell weight 100%. Or if we use only 70%, we can change to be 0.7 like that. So in this case, we want to use cell weight 100%. In some case, we might need to change the factor. For example, in some standard about wind load, we need wind and earthquake load. We need to change the moment of inertia to be only 75%, for example. But in this case, we use all 100%. So no need to change anything here. But the reinforcement, we need to modify it. Actually, our section is a assumed section. For this side to be, for the assumed section, we just want to create a section for analyze. So you don't need to do anything here. But if you want, it's okay. So for example, let's do this. So this one, our section here is a beam. So we choose beam and beam bar material. Okay. Longitudinal bar, we use deform bar. And for confinement bar, this one is a stirrup. We can use. Why it doesn't show? I want SD40. Sorry, SR24. Okay, why it's not here? Oh, here. SR24. Oh no, why it's not coming? Okay, we can set again later. So let's say use this one first. And top reinforcement, we don't need anything yet. Just press 2. And I think that's it. Just click OK. See now you'll see the section without reinforcement and click OK. I want to add another min. So just you can use the same property, just change the section. So I just add a copy and now change to be B2 and change the section to be 60, 30, assume it. And okay, let's modify limba again. Okay, beam SD40 hotbar. Okay, this is all still the same. No need to do anything. Okay, now just what is this? Oh, this is just the property that it calculates for us. So click OK. So beam we finished. So let's go to add column. Column is also similar to beam. Just we can use the same property and change to be column 1. And now change the section. Column is supposed to have the uh, symmetry shape, unless we need to decide to resist a very high moment. For example, due to lateral load, maybe we need to use 40 times 30. So the column may be in rectangular shape. This one can resist more moment. However, in this case, just gravity load, so it's okay to be like this. And modify rebar. This one is a column, so we click to be column and rectangular reinforcement rectangular. Use tie stirrup and oh, this one is important. It's like sometimes we need to uh, set this section to be analyzed or to be designed. What is be analyzed and design? Design is like we assume and then after we get the analysis result, we will decide it. But to be checked, to be checked is like we already have the section and have the reinforcement. We just create it to recheck it to check the strength of it. So in this case, we want to do the structural analysis for design. So we choose reinforcement to be design. Okay, I think not really important to set anything yet. So just change to be design and click to be column. That's it. Okay, now I think it's complete now for the beam and column. So what is the next? Next is about the slab. So slab is do the same way. Go define and section. Go slab. Select slab or deck system deck sections. So this one I will use slab. Slab there are two types. One is cast in place uh, and reinforced in the form of slab one, and the other the program set us to be plank slab. But if we want a new slab, we can. If we want to create our own, we can create it. Okay, let's say create one, and this one I want it to be cast in place slab. So I'll name it S1, and the concrete strength I will use S FC Palm 240 kc and national data. This one no need. Just this one is quite important. This one uh shelting, sheltic, membrane and layered. So shelting is used for cast in place slab, and sheltic I think they use mostly for foundation, for example spread footing like that. And membrane is the slab that cannot transform moment, the sorry, cannot resist moment, or how to say it. And the way is that it transform all the moment to the beam. It does not take any moment. Okay, so in this case, cast in place. So we want to be shielding and color. Okay, color is okay. Now thickness. Let's say we use 12 centimeter. Now that's all. Just click OK. Now we get a slab here. Now I want to add another slab. S2. Sometimes we may have the interior slab and exterior slab. So let's add a copy and name it to be S2. Shell-thin steel because it's a steel cast in place. But change the slab thickness to be 50. Okay. How about uh, precast slab or one-way slab like that? Okay. To create precast slab, we can create a new material or just use anyone here to modify it. It's very easy. Okay, let's say I just use plank slab and modify it. Just change to be precast. So I will say plank, precast, precast slab, and use the strength to be okay. If is precast is supposed to be, I think it's supposed to be high strength concrete. So I use FC Palm 280 kc. And the most important part is this one. We need to change to membrane. This one is because precast is like simply support slab. So change to membrane, and we use the special this one. We need to change to use special one-way load distribution. Mm. And the thickness maybe just 15. Mm. Precast plank slab is one way. Please remember that. Okay, now how about how about uh, the slab in the membrane, but it is still cast in place. So it's also okay. Let's say this one is S3, but we use okay, we use to be membrane. It is still okay, but this one is like uh, one panel, one shell that just put on the top of the frame. So it only resists vertical load. It does not have transform any, it does not absorb any moment from the beam. So okay, it's still considered as cast in place. And we don't use one way, special one way. We don't click this one. Okay, this one it depends on the purpose that you want to design. Okay, now we have all type of slab already. If you have footing, you want to create a slab and the footing, you can add new or modify. Okay, let's say add new. And this one I will say spread footing. Okay, and change the concrete to be this one. Now we change to be shell thick. Is because footing is a special shell, so it's we consider it as shell thick, and change the thickness to be maybe 30, mm, 30 centimeter. Okay, that's it. Okay, now we have every type of slab already. Now click OK. So now we define all the section already. We are ready to draw the model. So let's say I just use the default grid here. I I don't have the model. I just create a random model here. Okay, this one is random, and I want to check how many meter is that. Change the unit to be meter. Okay. Now right click and modify the grid. And story, we have file story and modify this one. I just want to check it. So each interval is 8 meter. Okay, 8 meter, 8 meter. Now, first of all, we need to draw the column. So to draw the column, go elevation view and click OK. Now we have this one, and go to draw, click draw tool, and select the member that we want to draw. For example, in this case, we need to draw column. So we choose the section that we already set the property, and then draw the column. Make sure you use the snap command, so it will show you the red point here. It's very accurate. If you don't use the snap red point, it sometimes if you have the shift a little bit, for example like this, it's not exactly at a joint. it's gonna be like this. So it's not gonna be good. Oh, if you have to find the mistake later. Okay, draw column. So I actually I have to draw all, but sometimes it may take time. So you can draw manually like this, but I'll teach you how to make it faster. So just select the column and go 3D. We use the copy method. So now go to edit. Make sure you select the frame and go edit. Now choose replicate. Replicate. Okay, replicate. Now we choose the linear uh, function and make check the coordinate. Check the how to say axis. So I want to draw the column to this side first. So I'll use y to be 0 and x to be, the interval is 8, right? So each interval is 8. And the number 3, because there are 3 columns here. If they are not symmetry, we need to do one by one. So now apply. You see? Now it's here. And I need to draw the column order here. So just again, select all column. And now we want to copy to y direction. So just change x to be 0 and dy to be the interval also 8. And the member also 1, 2, 3. So 3 line 2. Now click apply. You see? It show the preview. Okay, click OK. Now done. Close. Close. Okay. Uh, okay, I want to escape first. So now we get all the column already. Okay, I want to set the support first or later. Okay, let's set the support. Support. Go to assign. Select all the point first, and then go to assign. Join restraints. I want to change to be fixed. Okay. Now all column are fixed support. And next is to draw the beam. So to draw the beam, we need to go to plan view. Let's say draw in story 4. Another command. Let's go to the bottom corner here. You see one story. So one story we can only draw in one story. But if our model is symmetry, we can use the all story command, all story function here. So when all story function is like you draw one story, but it copy to all stories. So now I use the all story and select draw, select section to be beam 1, the beam that we want. So let's say the corner beam, I will use beam 1. In this case, I will use only the continuous beam. I think you're supposed to draw the section by section like this, but I will tell you the method how to change it again. Okay, so the middle beam, I want to use beam 2. Draw and right click to change the location. Don't click escape. If you click escape, you need to go to, it's like you escape the command and you need to go to click again. Okay, now I finished. I just, you can click escape, press escape. And if you observe, it is like a continuous beam. See, I click the mouse to the beam and it's like continuous beam like this. And if we go 3D, now we only see one view, right? If we go 3D, you will see that, see it automatic copy to all story like this. This is sometimes it's quick, but it need to be symmetry. Otherwise, we cannot use the all story function. So the next is I want to separate the beam here. I don't want to be continuous. So to make that, just select all member and go to edit and change. Okay, edit frame here and divide frame. So in this case, we want to divide the frame at the intersection point. So the column and the beam intersect, or the beam and the beam intersect, they will break it. See, like this, the preview one, or click OK. Now we can zoom in, click, it will only be 8 meter. Right click on it to check the length. So go geometry, and we will see the length is 8 meter only. Okay, now we finish the column and the beam. The next step is to draw the slab. So slab, also go plan view again and select all story again. So for drawing slab, we can choose the polygon or rectangular or quick draw tool, rectangular. Okay, let's say the first slab I will use polygon, and make sure we choose the right slab to draw. So we set assume this is a cast in place slab. Okay, click on S1 and choose the point to draw polygon. You need to draw the line, connect the line to be a polygon. Come back to the same point and you get a polygon here. So you get a slab. So how about to make it faster? To make it faster, we can use the quick draws tool here. Click on it and choose the slab type. And this one, we can choose the area that we want to draw the slab. So just click on the area, it will automatic draw. Okay, the middle one, I want to use precast. I want to use precast slab, just change to precast slab, and it is one way. Okay, we can see the slab is in this direction. The slab will transfer the load to this beam and this beam only, left and right only. So what about if you want to change the slab to transfer the load in the north and south direction? That is very easy. There are two ways. You can right click on the slab and go geometry and go assign, and then choose the local axis 2, and change default to 90 degree. Okay, now let's click OK. See, our slab direction change already. On the other way, we can click the slab, choose the slab and go assign. Assign and choose shell, and then choose local axis. Choose shell and local axis, and change this to be, for now it's 90 degree, so I want to change to 0. Just click OK. Now it changed back to be 0. And it also shows the local axis for each slab too. But okay, if you don't want to show it, just go assign and clear assign. Okay, they are gone now. So now let's go 3D. Now we already finished drawing here. Wow. But this is still an element. So if you want to see better, to be more beautiful, we can click this one, go display, set display option with the click icon here and choose view by section property and extrude extrude. This one is like to see the full section. Nice. Look at this. Okay, that's it for this model. Now you know how to draw the frame and the slab already. So the next step is to apply the load and analyze. So I will do that in the next video. Thank you very much and see you next video.